hypothesis, because all tests are designed to test neutral point, null hypothesis. Here are some examples of null hypothesis. So for example, you are testing there is no significant association between gender and frequency to go to gym. Both variables are numerical or nominal variables, gender and frequency. So test is chi-square test. There is no significance difference. The second null hypothesis, there is no significance difference in time spent in gym between male and female. One variable, which is time, is metric or numerical, and the second variable, male or female, is nominal categories. So if that's the situation, you are comparing time spent by male with the time spent by females. You are comparing 2 meters between 2 groups. Test is 2 group comparison is independent t-test of 2 samples. Third hypothesis, there is no significance association there is no significant difference in time spent in gym among lower age, middle age and upper age groups, because you're comparing time spent by 3 groups. So 3 groups are categories and time is metric or continuous variable or a scale variable. So if you're comparing more than 2 groups, the test is ANOVA. Fourth hypothesis, null hypothesis, for example, there is no significant relationship between time spent in gym activities and body mass index. So relationship between time and BMI both are measured on metric variables or scale. So the test is correlation Pearson test. On the other hand, hypothesis 5, there is no significant effect or impact of time spent in gym on activities, gym activities and on body mass index. The test is regression test. So these are examples. Please remember, these are examples, and it shows you what kind of, you can relate with your research and see what kind of hypothesis will work in your situation. So Z test is same as T test for us. What we are doing, we are comparing samples based on normal distribution, which is known as bell-based distribution. If your data is not normal distributed, you can't apply these parametric tests. You have to think of some non-parametric tests. This test tells you what is the percentage of people which is under confident, 95% confidence, and what is percentage of people who are not under that. It tells you the kind of errors you perform. Generally, for our purpose, we test our hypothesis by running the test on Excel or SPSS and work out some numbers, and those numbers are known as p-values or significance values. So you are always looking at the p-value or significance value which is coming from the test. Now if p-value is smaller than 0.05, then you reject null hypothesis, which means neutral point is not true, so possibly alternative is true. On the other hand, if the null hypothesis is larger than 0.05, 5%, 5 over 100, then you do not reject, which means null hypothesis is true, so male and female are equal or there is no relationship between them. So this, just remember these figures, 5%, because we want to be 95% confidence in what we are saying is true. We are allowing only 5% error, so we are not allowing more than 5% error. So that's why our rule of rejection or selection or do not rejection is 5% or 0.05. So remember the rule with the poem: small is beautiful to reject. Yeah, small is beautiful to reject null hypothesis. So if your null hypothesis is smaller than 0.05, then you reject null hypothesis. Small is beautiful to reject. Remember this. Okay, we said chi-square test, if there is no association between groups, for example, no significant association between brands and income, there is no significant difference between association between income and gender. This kind of test is chi-square test. The table is a cross tabulation which looks like this, and the test is performed by analyze, non-parametric test and chi-square test. This is another method, I'll show that. Now, if the hypothesis there is no significant difference of customers with satisfaction between male and female, or between Asian and British, or between lower and middle upper groups, if you're comparing two groups, as we said, t-test. If you're comparing more than two groups, you do ANOVA. So two tests, two samples t-test, more than two samples ANOVA. We also said how we do it. So to do comparison tests, the choice is analyze, compare means, and independent sample t-test. Two more tests are correlation and regression. For example, how much linear relationship is between two variables and how much is the effect of one variable on others. The tests are correlation and regression. Correlation can be positive. If one goes up, second also goes up. So if ad goes up, demand goes up, is a direct correlation or positive correlation. It can go from 0 to +1. And a negative, second diagram here is showing negative correlation. So if one increases, second decreases, price increases, demand decreases. Negative correlation, again, it can go to from 0 to -1, either -100% opposite, or -0.5, or -32, or -0.2, whatever numbers, negative. And if you get a correlation coefficient of 0, then your 3/3 diagram, there is no relationship between the variables. If you draw that line and then draw a line through those points and then draw an equation of the line, you have equation like, for example, y equal to ax v. This kind of relationship is known as regression line. So when you do SPSS, actually you're finding the equation of the line. Okay, let's now work for the qualitative theoretically. So same way, the qualitative starts with codes and the themes and content analysis. So section 1 is sample description, where you cover about the sample and from where the sample was taken, and then some information regarding sample, and then specific test of content analysis or template analysis or code or theme analysis, which you cover. You put diagram to analyze the data and show that, and you do, of course, analysis. Visually, qualitative analysis is when you read interview, when you type interview, then you read it. For example, here somebody is asking question of what they like the course, and the students are saying, I appreciate how much instructor encourages us, and then says how possible response to us. So each paragraph is read, and each paragraph is given a underlying name, an assumed name. That name which you assume as a title of that paragraph is known as code or initial code. You refine those code by reading more interviews of other people and so on, and then you have the focus code. Then you combine codes which are close to each other. You make them themes. So that's a process, and you can do in either Microsoft Word, or you can do in NVivo, or you can do manually this kind of analysis. Okay, these are some of the references. Now coming back to SPSS, as we said. So here is our data in SPSS. So first I'll show how the data is put. So in SPS there are two views. One is known as data view. When you open, this is quite blank, and data view and variable view. Data view and variable view. In the variable view, you put your questions. So first question is ID, second question is what is your gender, third is age, fourth is reasons why they go, frequency. So you name each variable, just short names. If you want complete name, then use this column label. So gender, what is your gender? You can copy paste from your questionnaire. Age, what is your age? And similarly, you can write everything here. Okay, if you want a complete question. Here on the variable name, it takes only small names without gaps. So make sure your variable name is 7 to 8 letters and is continuous without gaps. And then also each variable, for example, gender is male and female. How do you tell the software that thing? You, under the values, you choose, so values, for example, in front of gender, and then tell the software one. So for example, if I show here, if I delete it, get rid of that. So whenever is one, I write 1, it means male, and add. And whenever I write 2, the software should understand as a female. Add. and then you OK. So because when you enter the data, you have to enter the data as 1 and 2. Similarly, for reasons why they go to gym, you click on this under values and then put, for example, 1 reason for relaxation, 2 for maintaining. You put each region and then you click OK. So you do this for all the values, because each question you have alternative. So you tell software what were those alternatives, 1, 2, 3, 4, or strongly agree, or always neutral. You tell software. This is important to tell. Also, if it's a missing value, you can declare missing value under here. Now there are different kind of data are there. If the data is category, you classify as a nominal. For example, our gender is a nominal data. Age, if you are asking continuously, this kind of data is a scale data. Strongly agree, disagree scales, there is a conflict, but many authors still agree these are scale data. And if it's a ranking order, you say you can put that is a kind of what is known as ordinal data. So most of data can be category, which is nominal, or a scale if you ask a question, which is a strongly agree, disagree scale. Now coming to entering data, once you're done this job, it means your questionnaire is ready for SPS to write, and you go to data view and start entering. So first question, first person, in first column, ID, write his ID, say 200 number was that, he was male, write 1, his gender was, his age was category 2, or exact age was 34, whatever you tell. Reason of going, he is mentioning 4th reason. Frequently, he is going always. So you go putting, so each person you start putting those answers here. So one person, one row. And once you're done, you have all the data in the form of this. So this is the first person, who is gender is 2, age is 18 years, regions for gym is 3, frequency of going to gym is 1. Weighing machine is 2. So different kind of machines people are going, and their body mass index of that person is the last column, and that is here 18. So this is some kind of things, okay, we are talking about here. So if you want to see those tests, so first, as we said, you do descriptive statistics, frequencies. So analyze descriptive statistic frequencies, choose the variables. So for example, you want to do about the gender. So what do? You choose gender from the left, move to the right, and then click statistics, mean, median, mode, whatever you want, minimum, maximum, skewness, curtsies, range. Click OK. Charts, yes, I need charts. I need, for example, pie chart. Click OK, and that's it. We click OK, we got results. So here's the result. Gender wise, the mean is 1.53, median 2, mode 2, standard deviation 20, skewness 0.5, skewness minus 0.38, and here is percentage. So 32% male and 43% females, and sorry, I'm sorry, it's a 46. Here is the data because their system missing 20 numbers. So 38% male and 43% female, and there are some people who are missing from the system is telling us. Okay, if there is no system missing, you get the exact, and this is a diagram. You do this again, analyze. This time you do descriptive frequencies, change the variables. Say frequencies of going to cardiovascular machine, or let's say the time spent, and all the things. Statistics are there, chart is there. Let's change chart for this time. Let's say histogram, and show normal curve, continue. Okay, so here we get mean time spent on cardiovascular activity is 26 minutes, median is 25 minutes, mode is 22. I hope you understand the difference median mode. You have to read the mode. Standard deviation is 9 minutes, skewness is 0.73, which shows the curve is balanced or not curveless, so slightly positive skewed. And curtsies, the flatness and peakness is 2.5, so curve is slightly peak or sharp as compared to normal curve. And here's the total frequency of people distribution, and here's a chart of people distribution. So this kind of analysis is known as descriptive statistics. So you can do that by analyze, descriptive statistics, and frequency table. Coming back to the tests, so first test, as we said, is chi-square, descriptive statistics, and then click on cross tab. Yeah, note it, analyze, descriptive statistics, cross tab. You want to know the relationship between, so analyze, descriptive statistics, cross tab, and we want to know, why is it not coming? Analyze, descriptive statistics, cross tab. Yes, here's that, and you got a table. So we want to know the relationship, as we said, remember hypothesis, the relationship between frequency of going to gym, let's put in the column, and your gender, let's put in a rows. And then statistics, we need chi-square, so chosen chi-square test. Cells, we want frequency by column, so percentage by column, we do that. And I don't think we need anything other else, and we click OK. So here's the result. It shows us there are 4 groups: frequency of gym, usually, rarely, never, 5, or always. 5 we have not coded, that should be coded that. And now if you look at male, and then if you compare male and female under usual category, males are 42% and female are more. If you compare rarely, then males are 69% and females are 31%. Now look at other side, people who go mostly, so never to, so or 5, or sorry, rarely people go, so option 4 and 5, you see 76%, 77% female versus 22% males. So it looks like male are more liking gym as compared to females in this diagram, but you don't comment unless you see the p-value, as we said. So look at Pearson chi-square test, and chi-square value is 11 and p-value or significance value is 0.012. As we said, small is beautiful. This 0.012 is less than 0.05. Yeah, it's 0.01, so less than 0.05. So we reject no association. We conclude there is an association between gender and frequency of going to gym, which means male go, more percentage of male go to gym. In case of so more percentage of females go never, and more percentage of female go usually, 57% versus 42%. So you see the pattern. Then let's run once more time. Analyze, descriptive statistics, and cross tab. And this time, let's say between gender and reasons why they go to gym. Any relationship. So here is the data for relaxation. 33% male and 66% female said, looks like more female. Maintaining weight, again females are higher. Losing weight, quite high difference, 24% male versus 55% females. So looks like on welding strength, males are quite high, 94% by 5% of females. But you don't comment, there's an association unless the test says. So look beyond, look at down, and you see chi-square test. Chi-square, Pearson chi-square value is 0.000. Small is beautiful, is la to reject. So you reject no association. So you conclude there is association between gender and reason for going to gym. So then you can conclude more male go for building strength, 94% versus 5%, and more females go for relaxing or losing weight, 24% versus 75%, and 32% versus 60%. This is how do you write. This is the first test, which is test of association. Both variables were nominal variables. The second test is comparing male and female. So I said independent sample t-test, and we are comparing say time spent on cardiovascular activities, and we are comparing between male and female. So gender goes under group. You tell software the group was 1 and 2. Remember the code? We had done 1 and 2 for male and female. And click continue. Options, I don't think we have any options here. And okay, just come here. We don't need it. It's just a formula. Run the test. Okay, so here is the result. So we get time spent by male is 27%, by female is for 25%. 25 minutes. Looks like male spend more time, but don't set unless t-test says, and the t-test is t-test for equality of the means. So look at the second row is better always to look at. So second row, and not the first Levin's test, but here the t value is 0.325. 0.325, this guys, yeah, 0.325. Is it small? No, it's large. Is larger than 0.05. So we do not reject the null hypothesis. The null was there is no difference. We do not reject. It means null is 2. So we found, although from the sample looks like there is a time difference between male and female on cardiovascular exercises, but in reality in the population there is no significant difference. They all spend equal around 27 or 25 minutes. Okay, they don't spend different time. Let's run the same test again, but this time we do for independent sample t-test. Time spent on weighing machine. So maybe we're expecting maybe male spend more time. Time spent on weighing machines. So same thing. Click OK. Okay, so male spend 18 minutes, female spend 12 minutes from this charts, but don't say they are spending different time unless t-test here second row equal variance not assumed. That's always safer to root. You are looking at significance two-tailed 0.001. Good. Small is beautiful. 0.001. Small is beautiful to reject. So you reject equality. You reject male and female spent equal time. So if you reject, it means you approve that male and female spend different time. So there's a significance difference between male and female time spending on weighing machine. Male spend much more time, which is 18 minutes, as compared to female, which spend just 12 minutes of the time. Okay, this is how you work out. Now if you are comparing more than 2 groups, so you use ANOVA. So this is the ANOVA, and we are again, for example, comparing time spent on weighing machine, and we are comparing by age groups or the people. So is the category of the age. Okay, we need something here. Maybe descriptive statistics under options. That's good ideas. Maybe mean plot also here. And anything in the options? Yeah, we've done it. Okay, and okay by default things. So here comes the time. If somebody is less than 30 years age, time spent is 16 minutes. If somebody is 31 to 40 years, time spent is 13. If somebody is 40, time spent is 12. You can see that more is the age, less is the time generally. Yeah, looks like the downward trend. However, hold on this conclusion, because your test value is 0.093. It is not smaller than 0.05. So you cannot reject. You cannot reject of equal time. So you have to say, in my sample looks like time is different, but in the population they spend almost equal time. That equal time can be around 14 minutes or so. Everybody spends the same time. So you have not found any significant difference by age. This could be because of sample size is small or other things, but there can be range of regions we're getting. So this is ANOVA. Run again, compare ANOVA, one-way ANOVA. So let's change to time spent on, say, cardiovascular machines by age. See here, here's the result. So younger people spend 27 minutes, and then 28 minutes and 23 minutes. Looks like decreasing. However, hold on, because p-value is 0.206, which is larger than 0.05. You cannot reject equal because remember I said only null hypothesis is equal, and we always test null hypothesis. We are not testing neutral alternative, so we always reject or accept null hypothesis. So because this p-value is larger than 0.05, so we cannot reject, we have to accept null hypothesis, which was nothing but equal time spent by all people. Okay, so this is test 3. Correlation is the next one. So we want to see the correlation between time spent on weighing machine and body mass index. So let's say time spent on weighing machine and body mass index, which is the weight of the people, and the Pearson is already chosen. I don't think we need anything, and click OK. Here is the result. Strangely, result is negative. Negative means there's a negative relationship. This can be error anyway, but we're looking at, so first you look at the significance value, two-tailed 0.000. So yes, the result is true, and the value of the correlation is minus 0.427. Yeah, so what we're getting here, we are saying medium, negative and significant relationship between time and BMI. More time you spend on weight machine, less BMI you have. Yeah, so more time you spend, smaller is your BMI. Less time you spend, more will be BMI. Obviously, so more you work in gym, less will be your body mass index. That's the relationship we are getting. So that's how it was that. So let's work this again. Correlate, bivariate. Let's work on BMI with time spent on cardiovascular activities. This time, let's see relationship. We're getting a positive relationship, but significant 0.04. First, always check significant. Don't claim on correlation coefficient before you look at significance value. So 0.04, which is smaller than 0.05. So now you can reject null hypothesis, and you can think, yes, there's a relationship, but relationship is not very strong. 0.218 is mild. Remember, you can go from 0 to +1 or 0 to -1. It is close to 0, so mild relationship, positive. So more you work, more BMI you get, okay, in the gym. And the last is regression. Let's linear regression, and we want to know relationship of body mass index with people's time spent on body. Yeah, let's say one variable. Yeah, we can do others also. So, and statistics, we do anything, maybe descriptive and partial parts here. It's good. Plots between dependent and residuals. Histogram and probability system curve, and then run the test. Okay, so we're getting this regression results. So it's telling us mean of PMI was 30, mean of time spent was 40 minutes, and then Pearson correlation coefficient is between BMI and time spent is minus 0.42. So same thing, which you already see that. Okay, and regression model, the R value, the correlation coefficient 0.42. See, already see. R square is very important, or adjusted R square is more important, 0.173, which tells us that my model is only 17.3, so only 17% true prediction. So I'm explaining BMI with time spent on weighing machine. Only accuracy of my prediction of BMI based on time spent of the weighing machine is 17%. Good model? No, of course not good model. I need 70, 80%, 50, 60% right answers, not the wrong answers. Anyway, this could be because there are many reasons of BMI. It's not time spent on weighing machine. So that's why we're getting answer of small correlation adjusted R square. The second table is ANOVA, which is 0.00. So it says the correlation, linear correlation is true. So don't worry. So we've done that. And the most important table is coefficient. and we are looking at this coefficient, time weighing machine. This coefficient is significance 0.00 you see. So that's, yes, there is a effect of time spent on weighing machine and body mass index of the persons, but that's in fact is negative 0.565. Okay, let's run this again with multiple variables. This time I'm using correlation with multiple variables or multiple correlations. So I'm spending time spent on weighing machine, their exact age. This age is their exact age in years, not the group. Please remember, we can use continuous variable only. We can't use categories in regression. So exact age of the people and time spent on cardiovascular. Let's put that also. So 3 variables. We are saying body mass index is affected by 3 factors. One is time spent on weighing machine, second is the age of the people, and the third is time they spend on cardiovascular activities. So 3 variables are affecting body mass index. Let's see the results. Okay, so here is the mean value for BMI is 30, for time spent in 14, on age, average age is 33, time spent on is 26, mean correlation coefficients are shown here. So BMI time is -9, wage, good relationship, more age you have, more BMI, more fatty you become. More time is spent on cardiovascular, more BMI you get. Okay, so weighing machine is better. And then we have important tables, regression tables. So here is our correlation coefficient 0.8, good. Even adjusted R square is 0.64. So now my prediction of BMI is more accurate. So I'm able to explain BMI by 3 variables much better than what I do with a single. Remember, in the single variable the value was 0.17. Here is that. Yeah, 0.173. But if you add 2 more variables, my prediction become more better. That's what is more factors, more explanation. So here I'm getting our R square is 64, which is means 0.64, which is 64%. More accurate model is better. Remember, if a bank is searching for the customers, potential customers to fraud, we need a model which is more reliable and more accurate prediction. So better, higher is adjusted R square, better is your regression model. This ANOVA table simply indicates there is a straight line relationship. That's what is true, so don't worry, we passed through. And now see the effect. So effect of weighing machine significant, yes, 0.077 significant. Effect of age significant, yes, significant, less than 0.05, 0.00. Time spent on cardiovascular, again significant. All 3 have significant effect. Yes, all 3 has significant effect because all 3 coefficients are significant. P values are smaller than 0.05. What is effect? That will be from beta. So for 1 kg loss or 1 point loss of BMI, you need 0.1 to 1 point increase in, or 1 minute increase in weighing machine. If your age increases by 1 year, your BMI goes up by 0.8, which means after every 10 years of age going up, your body mass index goes up by 8.3%. Similarly, if you spend more time on cardiovascular, if you spend 10 minutes extra on cardiovascular, you add 2.79 more on your BMI. So this is also important to read effect. So weighing machine has a is decreasing your BMI, but cardiovascular and age are increasing your body mass index. Okay, and these are charts showing the final model. So of course it should not be normal distributed, so it's fine. They should not fall in the straight line, so our results are workable results. And then there's no pattern in the scatter plot, so our regression model was a strong regression model. I think that's what is a summary of the things which we mentioned. And summarize, we said that you are testing from the sample to population. So if you are testing association, you do chi-square. If you are finding the difference of the scores between two groups, you do t-test. If you find the difference of time or scores of more than two groups, you do ANOVA. You find the relationship between two metric variables, both are on the scale, then correlation. If you're finding effect of number of variables on one variable and everything is measured on a scale, strongly agree, disagree, or something like that, then you have a regression. Okay, thank you very much and good luck.